Hi all, in this we are going to talk about the linear regression and logistic regression using R. Okay, so this is also very easy, like we have seen in the rapid minor, it is very easy only. So we are going to take a data set called age and the height. Okay, I'll show you the data set age and height. Yes, so it's a small data set which gives you, like, if you get the age and the height and the number of the siblings, so this is the data set which you have. Okay, so you have got age and height. These are the two parameters that you are going to take for your linear regression. Okay, so now what you're going to do is that you're going to um, read the data. You're going to read the data. Okay, and the linear regression function in R is the LM. LM is the function. So this is the function, and in this function you could give the height and the age. So we are giving the parameters and whatever be the data which we have to apply upon. Okay, and now we are going to get the summary of the LM height. So this is the model. So when you look at the model, you could see that just a second. So this is the model which you get. So you have got the residual, the coefficients. So coefficients is nothing but the various this is the age coefficient and this is the intercept. So this is the formula, as you have seen. This is the formula which you will make, and this is the error with 10 degrees of freedom. So this is what you have seen, and there is also other parameters, like they have shown the standard error, the t-value, the prediction, and everything. And you could also see the r squared error here. Okay, so this is what which you could see. So when you write the formula, how you will write the formula is that 0.38, see here, 0.385 into x is nothing but this age plus 64.845. so this is what you will do. So you can give the different values on that, and you can find out, say if the child age is 20.5 months old, then you can give that and see, like, what would be the probable height. So you could see whether the predicted height and the height which is already there is almost similar or not. So this is how you will basically find out. So 20, so it is 78.1 almost, and here you are getting about 77.93. so this is how you will do on a simple simple linear regression using R. Now so this is about two different ones. So if you want to try it on multiple, you need to consider, say, both height and age. So here you have actually taken only age. So if you want to take multiple, what you could do is that you're also considering the fact that there is a number of the siblings. Okay, so you're taking multiple ones. So the number of the siblings also you're considering, taking into consideration, and you're applying this. So here you could see that you have two different things. So it will be like 1.303 into age plus minus 415 into number of siblings plus 56.5. This would be your so if you look at the number of the siblings, so when you look at here, this would be the formula which you will use. But basically this is a silly way of doing things, because the number of the siblings doesn't actually provide that much of information. So by these two comparisons, you could understand that probably you could take the age factor itself and could get a better representation. So this is what it is about this multiple linear regression. So this is just to show you, like, if you want to take multiple arguments, okay, you could take this, and this is the way you should do it. So you are taking two different arguments here, plus, with a simple plus. So this is what you have to do it. And apart from all this, I just wanted to touch upon something. Okay, the next one is the logistic regression. So I'll complete this logistic regression and then go back to something. So here there is another data set which is used, that is nothing but the it's a market share data set. So in this data set, if you look at it, you have various years of data which is given, and there is the lag values, and the volume, and today what is the value, whether it has gone up or down. So it's kind of a classification problem. and these are the previous values it has got, and so this is the data which you have. So it's a market share data, and now you're going to show the details. So initially it is just going to show the details, so I'm just going to show the details of your data. So when you look at the details of the data, you could see that it's a 5-point summary for each and every each and everything summary. You're getting the summary, the names, and the dimension of the data is shown here. And the next one is important. We are going to find out the correlation of the data, and where it is with -9. So we are keeping it as -9. So when we look at the correlation of the data, if you see, and the year, and now the other values are having a much better correlation. This is all like negative correlation, and here there is a lot of correlation. So we cannot find any major correlation between the data by our eyes, right? So when you look at it, the only correlation which you could see is the year, and the a little bit of correlation which you could see is year, and the this part is basic. This is better. Okay, this is having a better correlation. So year and the volume is having a better correlation. So this is what we are going to try and take for our data. So when you look at the the plot, okay, when you're going to plot it, so you're going to plot it by taking the various factors. So this is about your, so each and every day the values, and these are the shares traded in the billions, and this is the day, so how it actually has gone. So it just gives you an idea about how the data. And there is something called glm.fits, which will help you to get the logistic regression. So this helps you to get the logistic regression of the data. And if you get the summary of gl.fits, it's a function for the logistic regression. And when you look at it, okay,